This is a short video about a well-known theorem in graph theory called the Handshake theorem. Before we get started, I do want to encourage you to look at the in-class problems. It's in the file called Handshake theorem. It'll show you some examples so you can see the patterns that we are going to use to prove our theorem. So we're going to look at the relationship between the degrees of the vertices in a graph and the number of edges in the graph. And then we're going to use that to come up with the Handshake theorem, and then we're going to go ahead and prove that. So I just want to review a couple of definitions. First of all, I want to remind you about path graphs, PN. Those are graphs where if you lay them out, they look like a path. So this one is P5. It has 5 vertices, and the edges are laid out in a straight line. Cycle graphs are very similar to path graphs, except they go around in a cycle, so the first and last vertices are connected. Here's an example of C6, so it has 6 vertices, and they're all connected in a way that goes around in a cycle. And then finally, complete graphs come from, you have a certain number of vertices, and then every pair of vertices is connected. Here is an example of K5, where we have 5 vertices. Each pair of vertices has an edge between them. And one of the things I asked you to do in the in-class activities is figure out the degrees of all the vertices and add them up, and then count all the edges and see if there's any kind of relationship. Well, it turns out that the pattern is if you add up the degrees of all the vertices, that gives you twice the number of edges. And it turns out this is true not just for those particular examples, but for any graph. So let G be a graph with vertex set V and edge set E. If we want to figure out what happens when we add up the degrees of each vertex, well, the degree for each vertex, that's just going to be the number of edges that are incident to V. In other words, the number of edges that V is involved in. We are considering the degrees of all vertices, which means that all edges will get counted. And actually, if you look at that carefully, not only do all edges get counted, they get counted twice. If VW is an edge, for instance, that edge is going to be counted as part of the degree of V, but it's also going to get counted as part of the degree of W. And thus, when we add the degrees, that's going to give us twice the number of edges. In symbols, the sum of all the degrees of the vertices is equal to 2 times the cardinality of the edge set. So the Handshake theorem says that if you have G, a graph with vertex set V and edge set E, then the sum of all the degrees of the vertices is equal to 2 times the cardinality of the edge set. And one little sneaky consequence of the above theorem, since the summing up the degrees of the vertices gives you 2 times the number of edges, 2 times any integer is going to give you an even number, which means that if you take any graph, the sum of the degrees of the vertices will always be an even number. So if you didn't get a chance to complete the activities for Handshake theorem, you can go ahead and do that now. One thing that you must be able to do is to understand the logic behind the Handshake theorem and be able to articulate the proof on a quiz.